Good morning. Happy Sunday. Today's Sunday, yes. Totally can tell what days of the week it is without having to look over my calendar every single day these days. But how are you all doing? I need to move everything over so that way I only share what I want to share. All right, got everything moved over and quit. I think we're about ready to switch over here. Excellent. Everything is looking good from that side. I've got my sort of mid-morning tea ready to go. And we can go for a little bit longer than normal. I didn't get started as early as I was hoping to, but then again, I didn't go to bed as early as hoping to either. So ended up staying up a little bit past midnight, I think. But then let myself sleep in, so that was nice. All right, so as I alluded to on Friday morning, we're going to be doing something slightly different today, and I'm thinking all the Sundays from now on. So for today, I'm going to be building a. We're going to be working on a tutorial, and I guess it's gonna culminate in an end project that I expect whoever is taking this tutorial to be able to do. So I figured let's start with the end in mind, build that project, and then figure out what are all the things that are required for that project, and then we can build little micro tutorials for each of those aspects that sort of lead up to this. So that's sort of what we're going to be doing, and in a way, we're going to be creating the solution branch for this entire application. So if we take a look, I logged into my account on GitHub. And so now I have this basic Rust to do repo here that's completely empty, except I have initted an application here. So I figure let's go ahead and switch over to like a solution branch. Because yeah, we have these changes. They're adding like a git ignore, cargo lock, carbo toml. Yeah, I think this is fine. So what I really want this to do is just be like a solution branch. And I can then go ahead and push these up here. And push that up to solution. And we're gonna need to update. So let me open up Postman. I'm gonna update the command because right now I think bang repo is, yeah, it's the project we were working on yesterday and probably going to continue on Monday. So let's go ahead and update repo. Save that, and actually we'll say we're working on the solution branch. There, and I'll send that on up. And then our project is creating the final, sort of like the final project for a introduction to Rust tutorial series. And of course, it's a to-do app because all of the everybody who is like, you know, all of you who are familiar with like web frameworks, JavaScript, all that stuff, everyone does a to-do app as like that first thing when you're learning a new framework. Like you're learning React, okay, build a to-do app in React, build one in Angular, build one in Vue. Okay, you know the framework, you're ready to go on to like more in-depth and more interesting ones. Even if you don't have it like connect to a database or a backend, there's still plenty to learn about because all the credit features are there. So I figure this is an excellent sort of end of the first tutorial series. We hit refresh, we can come down to solution and see our code here. So this is fine. Now what I'm hoping to do is I'm hoping that we'll be able to not use any external crates outside of the standard library, if possible. We'll see what we're able to do with that. We're sort of like building this as we go along, and I'll fill out the README a lot better later. But basically, let's start with like our user stories. If I could spell that correctly. So I'm thinking for Bear Duda, good morning. I'm thinking for something like this. It's going to be simple CRUD. So I want to be able to launch the application through the command line and then be sort of in it in a loop almost, and then we're able to I guess we'll have a menu and we'll be able to then add to-do items, complete to-do items, and whatnot. What are we getting up to this morning? We are creating like the plan for our, well, I mean, I guess like for the entire stream, we're going to be starting and seeing how far we get into a basic to-do app through Rust. Then we're going to use that as like the final project for our tutorial, like introduction to Rust series that we're going to be like doing, you know, on the Sundays. Yeah. So I guess my target audience for this, who I have in mind, I have people who have just graduated, and so just graduated. They've got like their first job in like web development. So like I'm thinking JavaScript developers, probably using some kind of front end framework. Probably Node.js for the back end. I'm expecting that they have either self-taught and then they got their first job and they've worked for 1 or less years, or they've graduated from like a computer science degree or a minor, or a boot camp, some kind of like code school. And they like the centralized thing is they all have their first job in web development, and now they want to move on. They want to learn some other language that will give them a leg up when searching for new jobs, when trying to bring this back. Like we all know when you learn Rust, it improves your other languages. You know, the other languages that you know and use every single day. So assumptions, they know JavaScript. They've worked professionally, and so they know what that looks like. But they want to know a more strongly typed language that actually has, you know, many number types and other crazy things like that. Mark 2067, good morning. Hello. I am doing good. How are you? Okay, so as a user story, I want to be able to launch the application. So as as a doer, I want to be able to launch the application. And you know, that might be like not necessarily the best user story for this. Lord Mzte, good morning, hello. It might be something like I want to be able to see, to like add an item. It's like see my to-do items. And we can create like actual tasks that go under this to like actually lead us up to it. These are just like more of the higher level stories that allow us to like determine when it's done, right? Like when I can see my to-do item in the app that's running, that is done for this story. So as a doer, I want to be able to add an to-do item. Is this going to have a GUI or CLI? It's going to be CLI only. Because this is an introduction to Rust tutorial that we'll be creating for this, I don't want to use any external libraries. And right now, the GUI part of Rust is not really there yet with like the standard library only. And I don't really know if it's ever going to be there. It's probably always going to need some kind of external library for that, which always means it's going to be more of a mid-level tutorial. At least like after you get like basic introduction of how the language works. Let's see. As a doer, I want to be, so we've got the create, we've got read to be able to see my to-do items. How is the list going to be saved? That's a really good question. I'm thinking, so it's going to be one of two ways that we can deal with this. If I can figure out a way to clear the screen properly between each like action that we take, and what I mean by that is, can I do, yeah, so like if I do something like, you know, mark completed, like complete one, if I do that and then it clears the screen, shows the to-do items, and then your input down at the bottom, then I think we can just do this saved in memory only, and it resets as soon as you restart the app. There's no need for a database persistence. If I can't necessarily do that, I might end up using just file, like where we just save it and it becomes like a CSV, or yeah, probably like a CSV. Although like maybe not commas, maybe something else delimited like bars. Yeah, the problem with CSV is people often put commas into stuff, which then causes CSV, like pure CSV, to like be troublesome. But if I use like a bar, then I mean it's still technically a CSV, but it's no longer comma delimited. So which is a sort of like fun to then use the CSV word like that. Okay, so as a doer, I want to be able to mark a to-do item as completed. As a doer, I want to, okay, so we can create, we could read them, we can update with like marking them as completed, and then we want to delete. So I want to be able to delete a to-do item. And then just because I always think it's nice to be able to like actually quit things, as a doer, I want to be able to quit the application. All right. Just remember making sure the user doesn't type a bar. Like, yeah, no matter what you do, there's gonna be like always a chance that a user can like screw that up, which is why knowing the users can really help out with this. Now it's a tutorial; it's not that big of a deal for us, so it's probably okay. I mean, it's cool I can highlight these messages now, but like, I also want to go away. Matrix 17, hello, good morning. So I think this is probably pretty good for like the initial set of stories for this. Basically, like if this was an actual school and I was like graduating people and giving them certificates, these would be the grade points. I would be able to say, okay, look, can I see this? Yes or no. And also, I might like even put in a like screenshots of what this solution looks like. And if you can't make yours look like that, then you don't get full credit either. That being said, this is a free tutorial. It's not going to be something that's graded or anything like that. So it's really going to be self-regulated. But that's also a reason why having a solution branch here is so much more important. Because they can, whoever's taking this can then compare it against this. Also, I'll have this on, this video will be on YouTube, and I'll probably reference it in the solution branch, so people can also just watch and follow along. Okay, so as a doer, I want to be able to see my to-do items. Like, so what am I doing? Like, we're gonna just document as we do this. So we initialize a new binary Rust application. Out of curiosity, how many of you call our CLI apps or programs like traditionally or something else? Programs generally. Okay, so Bear, you say programs. Mark, you say app. Whom you're speaking to tends to have a bias in the context I use. Yeah, so like really old Unix devs, it will be a program. Lord, you don't understand the quit entry on the list. You're thinking the users enter one command and then the application does stuff and finishes, a bit like Git as an example. So yes, that is actually a really good point. This is going to be based upon this depends on how the app, I guess I go back and forth too, the application works. I think web developers are so used to application, like web app. I think we should use application in the context of this just to be like, look, it's just the same type of code. It just runs in your command line, in your terminal. Okay, so application works. We won't need this if we persist to disk and quit after every command. You'd call it an app even though you're not a web developer. Ooh, okay. Although like if anybody like mobile development, that's really where it came in, is like applications were mobile developers and the app stores, things like that. Really kind of co-opted that the words and changed the entire industry of how we named these things. But it doesn't really matter because I think people know what it means either way. Okay, so this is sort of going to be like we have to discover where we're going to go, and then this will become a thing if we go one direction or not. So we're going to initialize a new binary application. Now, if I want to be able to see my to-do items, we need to be able to like have some, basically data already in there. If we have a file that's going to handle this, then obviously that's something that we can just deal with right then. So we can try that to begin with. So under source here, let's create a new file. And I guess this could be like to-dos. Dot. I guess we could call it data. I don't think that actually matters what we call it. Yes, I know, you can help me. Don't. And if I put something in here, like how is the, well, let's say I don't have any data, like any metadata whatsoever. It's just like this is one line is the to do item. So if I say something like this is the first, actually let's make a to do list application. This could be our like first item, and then maybe our second item would be I don't know, play the drop game. So if I have these two, I want to be able to pull these out and then, let's see, pull these out of this file and then print them separately. So what would that end up looking like? We're gonna have to go to, I haven't done much file system manipulation in the like, it's been a long time, especially with Rust. So we'll have to go find that. I think it's IO. Is that IO to the file? It is. Okay. So standard IO. We open the file, which gives us a pointer to the file. We get a buffer, which it looks like we have to say what the size of the buffer is. Is that true? Or there is standard input and output. So this is how I can do things like read a new to-do item in. So I could do something like command, let's see, would this work like, let's see, how to use. So would I want something like name of the program? So I guess this would be our basic Rust to do space, then something like if nothing is passed in, it just lists list all to do items. So something like this. Whereas like add would be basic Rust to do, and then like add my new item. And then we can even, because like it's a tutorial, we don't need to like make people figure out that. We could just put it into quotes and then say, look, this is what the second argument in is what we use then. Let's start with this. You can allocate an array of to-do items of the length of the file with strings and then read the whole file in a loop. Yeah, that's probably what I'm thinking. Or we can create a vector. We could definitely create a vector. And the vector would then hold all of these to-do items. Yeah, I kind of like that, a vector of strings. So, whoop, that's whatever that, nope, didn't want that. Okay, so read from standard in. What I really want to do let's go to files here. Don't want to write to it. Okay, read the contents of a file into a string. Okay, this will be good because this will introduce this will force us to get into iterators. I could read the entire contents to the string and split on new line, and that will then like collect that into a vector. So we'll need file IO So we open up the file. We create a new string that's mutable. We read the content to that string. And then we can like print that out or something. So let's go ahead and start that. So we need fs file and io like the prelude. Okay, so once we have that, then we want to open up the file. I think splitting is not as good as an approach as reading the lines one by one. Splitting sounds like unnecessary memory allocation for the string you will split. It is unnecessary well, I mean, I don't know if unnecessary is the right word, but it is definitely not as good. Like if the file becomes bigger than the memory we have, obviously problems occur. So the question is like for a basic introduction for people who like are overwhelmed going into this new language, do we really care about that? Also, teachable moment, like they may or may not have heard of having to deal with that also. I guess my question is line by line an introductory thing or a slightly more advanced thing? I don't know. What can I do for reading line by line? Because this reads the full thing. Okay, reads the contents of file into a string. It says read to string. Is there a read to line? So this is off of whatever. Okay, it's a buff. It's a buff reader. Or is it read? Okay, so I have read to end. So that reads into the end of the file. That's not what we want. Read to string. No. I mean, okay, read vectored maybe. Buff reader. Okay, so buff reader has it. Let's go back there. Reader.lines. Okay, so it's a reader. It's the reader iterator. Okay, so it's an iterator over the lines of an instance of buff read. So this is going to be interesting to do an entire tutorial of how to use the documentation, because if you're not used to like going through this, it can be really easy to get lost, especially if you just don't know these things exist. The structure is generally created by calling lines on a buff read. Okay, so here it is. On buff read lines, returns an iterator over the lines of this reader. The iterator returned from this function will yield instances of IO result string. Each string returned will not have a new line byte. Okay, so it won't have the CRLF at the end, which is actually nice, I think. So we want to create our reader. And we'll call lines on it. So first we're going to open our file. So let do file equals I guess just file open. File open, and then our path is todos.data. And then the iter can be collected into probably a vector. That's going to be fun to explain too, is the difference between arrays and vectors, because in JavaScript, all you have are arrays, which are really the same as vectors here. But then there are arrays here, and so like your first thing might be to search for arrays, find that, and you go like, what do you mean I have to like give it the exact amount of what I'm putting into it, and like set it. What do you mean it doesn't know what the size is at compile time? This language sucks. But then it's like, oh no, there's better ways. Don't worry about that. Don't look behind the curtain yet. We're just gonna stuff all those things into the closet, and they can worry about all of them later. Okay, so we have our to-do file, which is with a result. So then we can probably unwrap at this point in time because we're in the main file. It's okay. I don't know. We'll have to get into like how to handle error handling at this point in time. But okay, so we get this. Get todos.data. Now we have our file. We want to create a new buff reader, but then hand it that new file. So that this is going to be our to-do file reader equals. I keep on doing command because I'm just so used to Mac at work. Buff reader is coming from IO. Okay, so we're getting it with the prelude, I think. Buff read, is it new? It is. To do file. Oh, a buff reader. Buff reader. Okay. Buff reader, so that makes you happy. And then of course, no function or associated item named new found for trait object dine. Buff read, we need to pull in self? Really? Oh, and you need to be a buff reader. Okay, buff reader new. To-do file. Okay, so then we have our to-do file reader. Okay, so now we can get our lines. So let's try just looping through this and printing them out. So for, I guess this will be a to-do item in to-do file reader dot lines. Let's print line. We can do something like ooh, I like this. And then to-do item. Now this is a result string error. So I have to extract this out first. So if let okay item to item like that. You're a string. Item is a string. Oh, yes. So I just want it to be item. Just like that. Okay, so then you're gonna go through and display all of them with this like sort of checkbox thing ahead of it. So let's do a cargo run and see if you can find it. Not found. Okay, so the system cannot find the file specified. So we're looking at to-dos data right here. Let's move this out here and see. Yes. There it is. Okay, so the file has to be outside of here. And here we go. We have make a to-do list application and play the drop game. And of course, if we have nothing at all, so if I cut you out, it should just still work. Yep. Okay. You're not that far behind, Bear, although you can use the drop game to discover exactly how far behind you are. Okay, so now that we have this, I think testing would be good too. Like somebody who's worked in the industry for a year, even if it's less than a year, should have been exposed to testing and the importance of that. So this will be important to have that as well, even if it's not like super like amazing test suites that like go through it. Just like a something to wet your teeth and like get you knowing like, look, there are tests for this. So if I wanted to do a little bit more of test-driven development, where does the integration tests go? Is that out here or is it in? It's not in source, right? It's in. I create like a test folder. Okay, yeah. So here's tests out in the root of the application, and then I have to. Let's see. Wrestling integration tests. So integration tests, this would be where we're dealing with like the file system. All right, so those are the individual tests. Integration tests. Okay, so we create a test directory. Create an integration test. Okay, so then it's as simple as this. We're going to use stuff. We mark it with the test. What is it? It's not. I guess it's a macro. We mark it with the test macro, and then we just assert. Okay, that works. Oh, it's an attribute macro, right? That's what it is. I learned that recently at the conference, is that those are technically macros that we are calling into, which is not something I really knew. Okay, so in tests, just attribute. I could swear that they also said that they are macros, or maybe you can create macros that get used in that way. Maybe that's what it was. All right, but in here, so this is going to be our integration tests for to do. So we'll just create all of our tests in here. So this will be like to do tests, rs. We don't need to do anything besides just mark it as with a test attribute. So function, and so then we should be able to get. Let's see. Get all to do items. I don't think this takes in anything. No, and it doesn't return anything. And so here's where we then call Now, so is adder can I do something like to do tests? Oh, it would be basic. Would I do something like that and be able to call main on it? Just to save confusion, just use attribute. Oh, there are, okay, so there are macro attributes, but in this case, it's just an attribute. Okay, got it. Okay, so I have to create a library file in here, I believe. Right, because I do have main, but you're not going to call main inside of here. We're going to call the library. So, and here we now see that it's yellow because it can actually find this. That's fine. So if we have like a struct for creating this and getting going with it, then that would make more sense. Okay, so get all to do items. Like how do we want this to sort of work? When using integration tests, it wants to test against the library. Yeah, and that makes a lot of sense now. Okay, so how does get all to do items work for us? We're gonna need, we launch the CLI application. It's going to, we don't pass in anything to it. And it's going to return the list of things to use. So I'm thinking that the printing of it would happen in main, and so we would just get that list back that we can then test against. So we probably want some kind of struct that we use that will like give us that. But like, I guess here's how we're going to use it. We'll have our basic Rust to do. We'll then call run and not pass in anything at all. So we'll have to like figure out the commands entire thing. So if we do this, then we'll have, okay, let basic to do runs. This is gonna be let our to do items. All right, so we run this, we create this, and if I run this cargo test, it should fail saying, hey, there is no run not found here. And so now we're in test-driven development. I've written the test, I've written the bare minimum of a test, and it's now yelling at me because run doesn't exist. Let's go ahead and create a public function run. And that causes it to pass again, so back to the tests, and sort of like continue to go around this. So let to do items equals that. Well, if I actually want to be a little bit more specific with this in my tests, I can actually say, you know what, you absolutely must return to me a vector of strings. Okay, now it's yelling at me that I'm not actually returning a vector of strings. So we'll now say that you return a vec of string, and then we'll just make this pass, return an empty vector. Let's see, actually this doesn't sound that good. The test shouldn't fail if there's no file, right? Did you get auto-modded? Hold on, I don't actually know how to check my mod. Usually I get like a message if like some mod thing happened. But I don't necessarily see anything. And I didn't get a message for it, so I don't know what you got auto-modded for. Well, we'll figure that out, Lord. Like, that's one of the things I like about test-driven development is that we've run into these problems earlier than like later on get through like a whole bunch of architecture and then discover everything is gonna fail. And there's test-driven development does actually require that a lot of refactorings while we're doing it, but usually those refactorings happen while it's still small, and then you have a lot of tests to help do the refactoring without screwing everything up. And I think that's what we mean. So, okay, now we're gonna return this vector, and then we're fine again. By the way, there's another word for, like, another way to describe this besides test-driven development. The hostile developer, I think, is a pattern that like I've heard it called. I really like it, which is as a tester, like put on our QA hat. Imagine that our developer is literally a hostile entity that, of course, is still us, that just wants to do the bare minimum of work. So if I say something like this, you whisper what I said to you, chat isn't posting it for some reason. Let me see if I can find it. For whatever reason, this didn't go through in chat. As an aside, since you are making an app, would working with units, tests, and not creating a library to backend your app create less confusion? Yes, I want to do both. So there's something called double loop testing, which I think we want to do. Yeah, I want to do that. Now here's like the problem around this entire thing. And perhaps this testing, like Rust testing for integration tests, isn't the right way to do this. Simply because it's not testing main. It's testing the library file, which unit tests can handle. I might want to like have some other testing suite. Yeah, it's interesting. Let's see. Mark, can I please explain the difference between vectors and arrays? Absolutely. So a vector and array are very similar things. Imagine that they're like this, two arrays. A vector is an array in a sense that it's a list of things that all have to be the same type. So let's do this as like vector. It's a list of things of the same type. But so then let's go down here. Array. List of things of the same type. Okay. So still in like the confusing, it can be the same thing territory. Vector. This can dynamically sized. So can change size at runtime. Whereas this cannot change size at runtime. Let me change from size to length. So what I mean by this is at vector, I can basically say, give me an empty vector. And then I want to, so for example, let my vec equals a new vec like this, and then I can do my vec dot push like 1. So this works. This absolutely works with vectors. It will not work with arrays, because if I create just an array like this, it's gonna say, hey, how, like, this is an empty array. That's completely useless to have an empty array that can't do anything. I can't push anything into it. I can't change its size at runtime. The compiler is going to basically allocate the memory for this array when it compiles, and that way when it runs, it's going to run at the same time, at the exact, like, as fast as it possibly can, because it allocates all the memory we need right then. Are you sure at runtime is right here? Pretty sure an array size doesn't have to be a compile time constant and can also be determined at runtime. I think, let's see, I would have to do this inside of our test here. Let's do this really quickly here. Let's see, mute my array equals brand new array like this. If I do that, we get an error, and it says type annotations needed for this. Okay, so let's go ahead and like push something in. So my array, there is no push. So if I now try to push that in here, no method name push for array. Arrays don't have push. Now, can I change its size? So my array dot I have length, I have partition. I don't see anything that allow me to like grow it. Bear, you have a good idea of going and checking the documentation for basic array? Oh, you're not saying arrays are resizable. You thought rest vectors work by having an array that gets switched out with a new one. Vectors. Okay, you're saying vectors basically work by having an array. I don't remember how they work behind the scenes. I do know, as Bear is saying, that they do some magic behind the scenes. Let's see. I want a vector with a capital. Vec. A contiguous growable array type. Now, are you being clever with that? Vec is a struct. What does it do behind the scenes? Can we actually go look at its source? It has a buffer and a length. So it creates a buffer with length 0 to begin with. So let's go see like push. Okay, here's an insert. I probably want a push though, because that way, like, if it runs out of size, what does it do? Here's push. Okay, so if self.length equals self.buffer capacity, okay, so we're out of space, self.reserve 1, then it runs some unsafe code. It adds, so as mutable pointer, add, and then pointer right, end and value, and then length +1. So Vex do some magic under the hood with pointers to give you the appearance of actually resizing. Yeah, so a vector in Rust is like an array in JavaScript. Yes, exactly, Mark. It is like an array in JavaScript. And that's where a lot of confusion comes in, is because arrays are different, but they share the same name as like arrays and well, I guess it's not, arrays don't exist in like Python. But it's like a list in Python and an array in JavaScript are equivalent to a vector in Rust. But it doesn't actually look like it's a true array behind the scenes that it's using. It looks like it's using a buffer that is then growing or resizing, that it's like changing size of. So it's, yeah, it's does that answer your question, Lord? I don't think that it's actually an array. At least I can't see that it's truly an array behind the scenes. It looks like just a buffer. Are you looking at the code yourself? Cool. If you find differently, let me know. Absolutely. I would love to know and like find out what the real answer is. Okay, so if I do to-do items like this, basic Rust to-do, we run. And I guess like if I do double loop testing here, I want you to be, okay, so before I even do this, let's say, I want to create to-do items and set it equal to this. So we run, and then we're gonna get, it's erroring out because run doesn't exist. Looks like it's doing manual memory allocation. Okay, so it's kind of like creating, like doing its own, like the same thing that an array would do, except without using arrays itself, which is interesting. Okay, so once we have this, let's now come in and we're gonna do double loop testing, which means now we need to add tests in here. And I forget, there's an entire way of like telling it that we're starting to do tests. Right, this entire config test. Looks like there's a pointer pointing at some memory, and when you push the pointer, moves forward and saves the element there. When you take something, the pointer gets the value at the point it's at and moves back. You've got the scoop and how vec works in memory. The Nomicon is the answer. Oh yeah, I haven't looked at the Nomicon book very much. I've heard about it though. In fact, there's a call for participants. Here's implementing vector in the Rustanomicon. You'll get to that section. Okay, yeah. But thank you, Bear Duda, for referencing that. All right, so we have CFG test. Did I do this wrong? CFG chest, and then, okay, mod tests. Like that. And then we can now use super to get access to whatever we're going to put into here. Like that. And then we're going to start building our test like this. So we know that we have to get a run going. So we're going to, okay, now we create our test. So function, we should like, what is like going on with here? Mr. Halsey raiding with a party of 42. Welcome everyone, and thank you, Mr. Halsey, for the raid. How was your stream? How's How's the server going in your game? Oh, was that what you're working on? And welcome everybody who came with you. Was good. You got a client plus server talking again. Awesome. That's pretty great. Login plus character management works. Ooh, I remember I was watching you like last week when you were when you got it. I think you got the server working again, and I don't think I've yet seen the Godot. I don't know the proper way of pronouncing it, but I haven't seen it working in there. That oftentimes you're streaming while I'm working, so I can't really truly watch it. All right, so we got a toggle music. Let me go ahead and pull that out. Here is my music. We are on synthwave. Where is synthwave? Let's switch to. We can try chill. I don't think I've listened to chill very much, so I'll be interested in to see how this sounds. But anyways, everybody, what we're doing here, I'm building a basic application that we're going to be using as a basis for tutorials, an entire tutorial series. This is going to be like the final project in like the first tutorial series. It's going to be an introduction to Rust for essentially web developers, with the idea being all you need is maybe like 1 year or less of experience of actually working. And it's assuming that you either self-taught or you getting, let's see. Oh, hold on. You want it off? Okay, I can turn it off. I can turn it off too. Let's see. Self-taught, like for a year or so, or graduated some kind of school. So like computer science degree, computer science major, or like a boot camp or something like that. So basically not like you're a junior developer. Let's see. Mr. Halsey, I know you have your puns, so I'll try to do this. I'll try to do this properly. What did one blade of grass say to another about the lack of rain? I guess we'll just have to make do. I like that. That's great. I hope it did it justice. Okay, so in here we're doing double loop test-driven development. So what that means is I have integration tests. I've written this test that basically runs this run file in here. Yes, I do have the drop game. We made it a little bit hard after there was maybe a tiny bit of war between my mod and Chantilly and Bear Duda. Where they created this giant V out of it, and so I started the platform moving, and now it's much harder. Let's see. So double loop testing, so this is function, basically like the run function works, like whatever that means. We can change these tests as we go in here, but basically like we have a run function. And what the run function is going to do is it's going to return the vector of it's going to return the vector of, what is it? Of arrays? Yeah, it's going to return the vector of strings. So can run the app. So we have like super, and so like let results, like to do items, equals, I guess, run, like that. That of course doesn't let us work. So now we're going to actually have all the code that makes this work here instead of updating this with like types or anything else. So now we're in the inner loop of the double loop. So let's go ahead and give ourselves a pub function run. And I could even do just function run and it'll still work here. Like that. Okay, so that makes this test happy. This test is still unhappy, but we're kind of in here making run actually do its thing. So then I'm going to say, well, to do items, you need to return a vector of strings. Okay. Well, we're back to this not working again. So let's go ahead and tell you that you return a vector string and we'll return an empty vector. Okay, that makes you happy. All right, back again. Fine. You're going to do that to me. I kind of actually do this to myself is like, you know, yell at myself a lot while I'm doing this and like be, I don't know, it gives a lot of pleasure during the work where I can take on two personalities and sort of like play myself off of the other one. Gotta go, Mark. See you next stream. Okay, well, thanks for dropping by. It was great seeing you, and I'll see you next time. Okay, so we have this. Let's now actually test that the first, like what the first item is in here. So we'll grab, let's see, we'll assert equals that to do items. To do items first, I actually want to check that this is equal to a very specific string. We're going to come to here, grab make a to-do list application, that in there, and equals to do items position 0. Right, so I hit save. Now we actually have to run these tests. So cargo test. Okay, so cargo test here. One warning, a function is run as private. Oh, I was really hoping that the it would run like the inner loop first and like actually run that, but it's yelling at me about this stuff. So hold on, let's make you public. Then that will make these tests happy. Okay, so now it's saying, look, it got panicked out of bounds. We don't have anything in our vector. Okay, that's fine. We should actually say, before this, let's assert equal that our vector is length 2. So 2 is to do items dot length. Okay. Okay, so now we got our first failure state. It is length 2, but we actually got 0 because our developer didn't put anything in here. Well, our developer is being lazy. So our developer now says, where is it? Right in here. Oh, Vec, let's actually create 2 items of strings like that. I guess we need to .toOwned each of these. Like that. Cool. Except make a to-do list application is supposed to have been the first thing that goes in here. Well, okay, fine. There we go. That works, right? Okay, that passes. So this is where we get to work on making our tests a little bit more, like a little bit better, because it'd be really easy for us to like just say, oh hey, we made like the test read these one things and it works, but like it's not actually as dynamic as we really want it to be. So how are we gonna end up dealing with this? If we want to run to like reach out and grab the data in here, we want this to be dynamic. Maybe that's not how we should end up dealing with this. Maybe we should hand it like the string buffer or like some other file. Maybe we need some kind of some way to like randomize what this looks like, but that will suck too because we won't know what they are in there. How do I want to properly like test this out? If I now say like I want the second one, so like if I don't want to hard code that in there, and I want to force myself not to hard code it in there, I don't know how to dynamically make to-dos data unless the main function is going to deal with all of the file, like the like grabbing the file and getting that. Okay, that's probably what it is. Just to let everybody know, for the drop game, there's no randomness whatsoever. It's got like the same speed for dropping, the same sort of horizontal movement. So therefore, it's just all about timing. The randomness is the lag. So if you can figure out your lag, you can drop like more. You could probably get hits more often. Okay. So let's do. If I pass into run the string of all of the to-do items instead of making it read into the file, testing the contents of the to-do file seems a bit too much. Well, yeah, and I guess like that's where like maybe we don't need to test that directly because those things are actually tested properly. And it's also why I'm like slightly upset that I can't test that my integration tests don't start with main. But if I say that I hand you the vector of strings, so let's say I do let like my to-do items, like my file items equals a vector of this and we'll need to own this. I pass you into run here. So this is going to be our, what do we call this? Our file items. Okay, we got an error state because of the run here. So we need to go up and change this up here. So this is going to be our file items, which is a vector strings. Get this back and then make a to-do list application that, okay, is this. There we go, okay. Make sure that your length is 2. And then we'll also make sure that the first thing is this. That should now pass. It does not. Oh, because our integration tests. needs our to-do list items here. If run takes a vector, what will it even do? Yeah, it's like, it's a good point. So I'm still getting still thinking about like how I want to deal with it, like similar to like other applications where I can have my integration test be a little bit farther separated out from the application. But if it not does that, so if I do maybe the file name, oh, that's what it is. I hand it the file name. I hand it the file name. There we go. So let's do file name equals a string, and then this is going to be todos.data file name goes in here. We switch you over to file name, which is a type, and so here we can introduce to static str, and then we can say, okay, we assert you're equal to 2, and then this should be the first item. So save you, and then I believe you are. So we need file name. So let's to-do items, and you're also going to be todos.data. Okay, so everything worked here. If I now add the second one in, assert equal, now at some point in time, this failed because we want this to be now equal to that. And it's saying, hey, your play the drop game doesn't exist. It's equal to this empty string. So at some point in time, our developer, who's us, gets a little bit tired of like constantly making these vectors like this. Now, what would be nice is if I could like dynamically make to-dos change every single time I run it. But unfortunately, I don't have a good way of like randomizing that data. I could use something like Faker JS and like have a wrapper for like the entire running of the tests, but that sounds like a terrible idea. So instead, we'll just move in now to doing this the way we're supposed to do this, which is down here, which is over here. So we're going to bring in all of you. And all of you. Okay, so we open up the to-do file. Our path is not going to be to-dos data. Our path is going to be file name. We get the reader. We then loop through all the files. Now this is printing through them. So now I want to collect this into the strings. So it's actually create, let's see, to-do item. Oh, it's going to be to-do file reader dot lines. This gives us a result. So if I want to, let's see, can I unwrap it? Can I just collect it? I can. And you're going to need some type. Can Cannot be built from an iterator over types of this result. Okay, so I need to map through this and change it, like handle each of the results. So we're gonna map. We're gonna have our function, which we're gonna take in each line. It's a result. So I could just handle this here with an unwrap. And then that will return out the string if there isn't an error, which then goes out to the string here. Let's see if this works. It does. Okay, so it works technically. It's not necessarily the best use case for this though, because I really want to handle these errors at the main level. So what is that going to look like here? I want to actually return a result at this point in time. So we'll have a vector of strings. If there's an error, I want whatever this error is. And maybe I should turn this into like an actual string. Easy error handling. Now, the problem here, okay, if we have a result, line unwrap, what are the points you get from the drop game good for? I don't know, nothing right now. I don't have them doing anything yet. Basically, it's just the ability to, and they reset every stream. I guess bragging rights for the day. I do want to have like a persistent points thing for it. So a map might not be best for this because I can't necessarily question mark like line. I don't think I can do something like line.question mark. Because this is returning, can only be used in a closure that returns result or option. Yeah, so let's go back to a for loop. So for line in lines. Now we have this result here, right? So this is giving us a result at this point in time. We want to check to see if it's an error. If it's an error, we want to return and basically turn it into a string. All right. Let's do a match statement for it. So match on line. If it's okay, so first of all, if it's okay, we want to take in the to-do item, and we want to have some kind of array. An empty vector here, we'll make this mutable, and we'll push this in here. So to do items dot push line. If it's an error, we want to get our error out, and then we want to take this error message and maybe like put it up on our string. So we want to return an error. Inside of here, I'm going to format error, like I guess error reading lines from to-do file, and then we'll put the error inside of there, and then this will return that out, and then at the very end, after this for loop, we're going to return the to-do items. But I can't just return them plainly. We have to wrap them in an OK for the result. Mismatch type, struct center vec, string. Found error, string standard IO error. To do items is to do item. That, like the actual string. Okay, there we go. So that returns that out. Okay, this now is mismatched types, right? We expected this. I did this wrong. I should have done the test first of like handling it as a as an error. I want to unwrap you, and then you work. So cargo test, and that works. Okay. So what else do we need with this for like getting the to-do items? I actually want each of these to-do items to really look like this. Okay, so if I run cargo test on this, we fail. So back up to here. We can't just push a to-do item like this now. We're gonna have to do a little bit of formatting for it. So let's actually create another function that formats the to-do item. Is that right? Or do I want to like actually just do this? Yeah, let's create another function for this and we'll call it. So let's just pretend it exists. We're gonna call format to do item and pass it in the to do item. Now one would think maybe I should be doing like a test on this to do item here. However, my test is handling this because it's testing to make sure that this works too. So I don't necessarily need to create this. All these lines will be tested for us. So this is gonna be a private function, format to do item. This is gonna take in a string. So to do item, we're gonna take in a string. Now I could take in a reference to the string, like a mutable reference to the string and mutate it in place, or I could consume this string and return a new one. Let's consume it and return a new one. And so all we're going to do is we're going to call format on here. Let's do item, and that will be what we return. Okay, and so there we go. We now have OKs across the board for this. And is that pretty much it? Like, have I correctly listed all these out? Let's try this. So if I want to use this now, the equivalent of our main of what we're going to put into here is get all of our to-do items by passing in here, and then we want to just print them out. So print line to do, I guess in this is like assert that the to-do items have this. I don't really know if like we even need these integration tests. I don't know if they're doing anything for us because it's literally the same because we have this like run inside of here. So I think I'm going to just delete these for right now, and we can bring them back if we need them later. In main, we're going to use, let's see, basic Rust to do. We're going to do let to do items equals basic Rust to do, run the name. So file name is todos.data. We have to unwrap, and then we're going to print line to do items. See what that ends up looking like. oh, it doesn't implement standard format display because it's a vector. So we need to actually loop through each of these. So for item in to do items. Item. Let's see, cargo run now. And so here's our 2 items. We could even do like other print lines here too. So like print line. This is going to be to do items. And now it looks a little bit nicer here. Lord Mizda, you toggle desk mode. Perfect. Let's switch over to standing. All right, so this is the R in CRUD. We have all of these now. So I guess like this is list them all out, right? So initialize a new binary REST application. What else did we end up doing here? So initialize we want to like get like open the to do items, the to dos data file for reading. We also like put them all, so let's see, put all items into a vector. And then finally, as part of this is like print the items to the screen. Okay, so that's kind of what we did. We want to be able to see all of our to-do items. And we're not going to need this because now we know we're going to just do it as a command line that we open up over and over and over again. All right, as a doer, I want to be able to add a to-do item. Add a to-do item. Patatas del Papa, good morning. Okay, so if I want to add a to-do item, what is that going to look like? I want to be able to do something like cargo run, then add, and then my new to-do item. That's kind of what I want to do here, which of course that's ignoring it. So what this really means is I need to grab now these things in main and be able to pass these strings in to run here. In Rust, we have all the classic web security vulnerabilities, SQL. So Rust, yes, I want to say yes. So SQL injection is really like, you can have a SQL injection in any language. It's really just about like the SQL language itself allows you to have like injections. And that's because you can have things like subqueries where like inside a query, you can like, let me just do more SQL code. It just is fine. If I get like a raw SQL driver in Rust, in Python, in Java, JavaScript, Java, it doesn't matter what language. If I create a SQL connection and then I just take raw SQL and throw it in there and I don't bother sanitizing data from the user, they could pass me SQL and it will execute as SQL. So you absolutely could. All languages, however, also have the ability to like easily mitigate that. And so eventually when it gets to tutorials that will deal with databases, I'll show how to like use these libraries to not even have to worry about SQL injection. Cross-site scripting, that's a web thing only. So that's where basically your JavaScript is coming in and like doing its own stuff. someone else's JavaScript is coming in and doing their own stuff in the context of your app without you really knowing what it's happening. This is a server application, meaning that I'm not gonna, like, nobody can just come in and do that. So yes, no, we don't have that that problem, but that's only because I'm not making a web server in this specific case. Cross-site scripting is also a front-end thing. So Rust is not going to help you. Even if we do WebAssembly, it's not going to help us there. Yeah, it's a very different environment doing like pure like CLI applications. And even Node.js will like protect you. Like you just won't have those problems. You have a completely different set of problems. Okay, so as a doer, I want to be able to add a new to-do item. Let's also git commit this. Getting all to-do items. Push you up. Okay, so if I want to be able to do something like cargo run, and then this is a command. So I want the command, and then I want like the item that's going to be, we could put in here. Ouch, get GUI. No, it's fine. It's growing on me. It's just, I think this is faster, and I don't really like feel the need to have to like type constantly for everything. And that's like so far the best one that I found. It helps that like my work ended up purchasing them for all the other team members that I have, and so I like to like make sure that I'm using it, so I'm aware of like what troubles they're going to run into with it as well. Okay, so add a to-do item. If we take a look here, we have a command, and then we also have the actual item that we're going to put in here. So we need essentially when main comes in, we need to like grab a command out and then pass that in here. Well, to me, that sounds like maybe we should have inside of like basic Rust to do an extract commands function. We pass it a string and it like figures out what those commands are. Maybe. Let's actually go take a look at what we have from the environment in here. Because I want, it's not vec, what do we have access to? For like, I guess it's not really standard input, it's our arguments. I think it's like args. Yeah, standard env args. Thank you, Bear. Returns arguments this program started with, normally passed via the command line. Prints each argument on a separate line. Okay, so it can just loop through here. Okay, for argument and env arguments. So this would allow me to grab it out via, like, okay, so each line, so we, inside of main, we would essentially do this and then get the command and get everything else. Okay. So let's have like a grab. Is there a way for me like set arguments for like as part of a test? I don't think I can. So I think I have to do this via main. And once I do that, then we're going to pass these in to run. First arg will always be the binary. Is that? It says this in here, right? With one element or more for testing. But yeah, I'm probably going to pass a vector, or we could have inside of library here, like extract, like get arguments. That being said, I'm really curious, like what do we get out of here? So let's use standard env args. So you give me an args here. So you're like an args type. So if I want to like extract that out, oh, okay, I can debug. Yeah, let's debug it. Arguments. See what it is. So here we have cargo run, add my new to do item. So here's args inner. Yep. Okay, I see what that is. We then target through this, add, and my new to item. If I list that out, can I create like an args object? Like, is it possible for me to create my own args? Inner argos. I mean, that doesn't, I guess there's a from. Can I create it from like, okay, let's take you. Just make a vec with one element being whatever a string. Okay, yeah, so that would be nice. So that's like my own arguments equals a new vector of first, second, and second. And then I want to create my own, like create these arguments. So here's args OS. So args OS from my own arguments. Will you be happy? Mismatch types expected a struct args OS found struct vector of string. That I'm wanting to create my own arguments. I was hoping that I could like deal with it this way, but apparently I can't. So let's not worry about like doing it, getting this out here. We'll get our arguments separately, and so that we'll have a command. Okay, so we figure out what the command is. We figure out what the command is, and then we have to figure out what this like new item is. And I think that should work. So we want command. So we want in our main library, save you back again. Let's create another test here. Function like get command. I don't know if it's get command or like test, like test figuring out what the command is. What I want to do is hand it a string. So like add is going to be the command add, which means we're going to have some kind of enum of the commands that we want to do, which is going to be the CRUD stuff. Right, args is an iterator that yields strings. So I can now like take out the string from it and figure out like, okay, well, like the first one is going to be the command, and the second one is going to be, well, I guess like the first one is going to be the name of the file itself, and so we ignore it. Then we're going to get out the what this is. I guess so. Yeah, we want to create like a command from this. So that's what it's gonna be, and maybe that could be is like part of run. Because I can do this as like take this in and also take in the arguments, which might work, or I can take this in and take in a command separately. Let's say I pass in the arguments here. So can run the app. So let's say it can list. Let's see, can add. This is going to be can list all to-do items. Like that. Function can add new to-do item. Okay, so I now want to be able to hand it the file name and the arguments inside of test, which then will figure out what like the command is supposed to be, and then deal with that. So if I do something like file name let's see, we figure out what our to-do items are, and then we test what they are. I kind of want to get all of them first, and then, okay, we're going to get them all. So let to-do items before add equals run. Hand it the file name, unwrap it, and we have that there. Okay, so that's fine. Assert equal two items before add dot length. Now, if I want to add something to it, so that's going to be a let to-do items after add run. So still our file name, but now we need to like hand it the arguments. So like arguments, and then unwrap this. Well, of course, we don't have arguments here, and I don't even have a list here, so let's create that. It's going to be a vector, and so there's the three things. So this is going to be like the process name, the program name, application name. Ignoring. And then there's going to be the command name, which is add, and then a new to-do item, like that. So we pass in to you. Now it's yelling at us that this doesn't work. So we have to now fix arguments here. So you're going to take in the arguments. Yes, I can skip one to skip the program call in the args when I do the iterator. And that's probably what we're going to end up doing. But okay, so in here, you're now going to take in the arguments, which is a type vector of string. Now, of course, that causes problems over here. So if I have like these two now need to take in this other, all these other arguments. Mismatched, construct. Oh, they are going to be real strings, aren't they? When they come in, so I should probably make them the same. So that because you saw me searching for argOS and he wanted OS strings. Yeah, and this will probably work because I can just like extract them out ahead of time and like passing them in. I can actually remove this. We can just say like we're going to at the upper level, pass in what this is as like the arguments coming in. We could even switch this out and say, just for niceness, that we're gonna pass in like the command, and then the new item, which would essentially be like an argument for coming in, like whatever it is that we want to pass in. I think it needs to be the arguments itself because this won't always be a string. Sometimes it might be a number because I may need these to have like IDs on them. So we're gonna have commands. Let's actually do, I like arguments again. So we have add, we have this. However, now up here we have problems because we need to like pass in the proper arguments. It's still going to be a string. You'll need to .parse. Yeah, the question is, do I want to like create a like data structure, like a command enum essentially that would then like store that in there, and maybe I can like do command enum new and like it'll that's where I do the parse. Let's see. So I want, for reading, for the get all, I want to pass in like nothing. So let's do let arguments equals a new vector. And that's essentially just absolutely nothing. So an empty arguments. And I might even be able to just get away with an empty vector like that. And there we go. So the tests are happy again. But we still have 2 errors. Oh, that's because in main, we're calling this with like grabbing the arguments out. So let's actually do that work here. I'll just create you right now and pass you in. Just to make you happy until we get our test working the way we want it to be. Okay, so if I do this, let's run our tests again. Tests are passing, so now we can continue building out here. What that means is we start with this one. We add in the new arguments. And then we want to test this again. So assert equal 3 is to do items before add dot length. Now you're going to fail because it's length 2. So let's go ahead and figure out how to deal with this. So first of all, how do I know that the first item of this is going to be a, well, add? And like, how do we know that it's going to be like read or something else? I'm thinking that we want some kind of like enum of a command. And so we're going to have like get all, like just list all, which would be nothing here. And then we're also going to want a add. And then with add, we want to put in here that we're holding a string inside of it, which would be the thing to add. But of course, how do I like figure out if I now have like a new command? So we're going to impl command. We can take in the arguments for this, which is that vector string, and we're going to return a command. And so we can put our logic for figuring this out in here, and then just like get the command out of like what we're doing in match inside of run. So what is this going to end up looking like? With commands, function new here, we take in the arguments. The first thing, well, okay, get the length of this. If the length is 0, we're just doing list. So if arguments dot length is 0, then we're going to return command list all. Okay. Now, if the first argument, which now we know it's like greater than 0, and it might be helpful to just do this as a return. And then down here we can say, okay, if maybe we can just match on arguments of position 0. If we have the string add, and maybe let's actually make this like 2 lowercase. I think I have to do this as like 2 owned here. I don't remember if it's going to match on this properly. But if it's add, we want to now return a new command, add, and then inside of here put arguments of position 1. Ooh, to ref. I like that. Then to ref. As ref. Isn't there like a to ref? I thought there was. As ref, there it is. Returns lowercase equivalents, okay. Non-exhaustive patterns. Oh, right, because like it's a string. What if it's just like something completely else? That length equals 0, clip will tell you that's more idiotic to do arguments is empty. I thought I had Clippy. I don't know why it's not yelling at me anymore. Maybe it's because I don't have RLS on. Arguments is empty. That's probably a good idea. Let's do that. Arguments dot is empty. Okay, so if we have no empties, then we're going to do that. Now in here, we actually need 2 arguments. Like we must have. So let's see. If arguments dot length. So this has to be greater than 1. It has to be greater. It has to be like 2 at least. So if arguments dot length is equal to 1, we did like add with nothing to add, and that's a problem. So if that's an issue, we should actually return a result that's going to have the command and then the error. Let's just put them as strings because that's how we're doing error handling right now. So we're going to return, this becomes an OK. That. We're going to return error. Missing argument in command, like that. And you are going to return an OK, like that. Oh, and you're a toString. Am I going to eventually change that string as the error type? I don't know. I was thinking for like the very beginning one is just like, look, our errors are strings. I don't know if we have like, what are easy error types that we can deal with? Can I like do it? I can't do like a new error, can I? I'd have to like create an error. I have to create an error that like extends, it implements the error type, don't I? That's what I'd have to do. And then I can like return that. Okay, so arguments. Yeah, if this is for teaching very beginner, I was hoping to like not use any external libraries though for it. And maybe for like immediately after that, it's like, okay, now let's like actually go into more like better rest. To do arguments 0. Okay, yeah, so non-exhaustive. So we also have underscore. What is this? Basically a reference to underscore, which I don't really care about you. Oh yeah, I could probably just do this. Yeah. If you give me something I don't recognize, we could assume that you just want to list out. So in that case, we want to return an OK, command list all. Cannot move out of index. Move occurs because type has string, which does not implement the copy trait. Can I clone it here? I can. Okay, so I'll just clone it over. So that way we extract it out. I would have loved to take ownership of it, but apparently I can't. Okay, so we have this now. So we have the command. We've extracted out into this tuple enum type. And so we have our arguments here. And so the very first thing we can do is let our command equals command new and pass it in the arguments. But we have to, we could then question mark this for the result here. Okay, so now we have our command. We probably want, regardless, we're going to open up the file for reading. We don't need to always push items into this though. It really is going to depend upon if we're like adding, deleting, removing, whatever. So with add, so let's go ahead and match on the command. So if it's command list all, we want to now do all these things. If it's command add, and so the add is going to be like the new to do item. What do we want to do? Well, we have our file reader. So reader actually can come down here too. Like this. We want to now open this up for writing. So that to do file writer. All right, file. So here's like write all. What I really want to do is like append. Is there something that allows me to like go to the end of the file and then add it in there? Still not sure of the string error handling for beginners. You would immediately introduce errors as types, enums, as that is a real way of doing the library in Rust. If this is an application, then simply box dine error would suffice as well. Yeah, I could do a different error, like my own error types. Oh, and then hold the string in there. That might work. And sort of like I sort of get in there. Let's do this, and then I'll think about refactoring that. So then create open length, set permission. I want to get a writer. Do I want a buff writer? Write has an append. I don't see it in here. So not this write, but maybe a buff writer has an append. No? You think it's okay, you think it's on file open? Let's go back to file. Actually, can I just search for append? No, okay, so it's not as nice as that. So in file, open options. So under open, see the open options open method for more details. Here's append. Sets the option for the append mode. Open options new dot append true dot open. Okay. Oh, so we even want to do like the entire opening of the file differently. So like this needs to be down here too. It's like to do open, it's going to do file equals file open. It's not even file open, right? It's open options new. Okay, so we need open options. Standard FS open options. So open options, I think it's just new dot append is true dot open and then the path name. So that's going to be the file name. That gives me a result with an error. So then I can just do the same sort of like match with this. I guess we can like take in error and then like bring in error and just say like, oh, well, this is just there's no way, there's no easy way in the standard library to like handle that. Although I really want to like deal with it. So if I match you, okay, so if we get okay, we're gonna have our file. I'll return our file. If we get an error, we get an error here. Now I guess like right now we just have this like return error format. But we can change this like soon to be like an actual error enum. To do error opening file for writing. Handling errors are done through types, which is why I recommend them early so they don't fight through all that map error and such. Yeah, I see that. Okay, so we semicolon you. Now we have to do file, which is our file, which we can now append to, which we are going to append to it. And so we want to actually do that. How do I, is it just write? So to do file dot write a buffer into this writer. Attempts to write an entire buffer into this writer. Okay, so we can, I think, just write, but we have to get our buffer, which is a vector of u8s. Can I grab this from like a string? Oh, it can convert into bytes. I mean, so if I try to say like, okay, the new to-do item, and you return a result with the u size, like what I put in here. And so I guess like at the end of this, I'm returning a result. You're returning this file like that. So that's interesting because like I don't need to actually return anything when I return it unless I get all of the commands. Like I get all of them again and like list them out again, but it's probably like let's just like new item, new to do item. Or maybe like we return just the string format added to do, I added new to do item. Like that. New to do item, mismatch types, expected struct, vector, standard string. Oh, because you're expecting a vector of that. New to do item, go to string, mismatch, so you expected a reference to it. But a reference of bytes. Let's see, 2 byte. Can I do 2 bytes? Or is it like as? pretty sure is as ref string as mutable vector as bytes. And then you cannot borrow to do file is mutable. Okay, so you need to be mutable. And then I need to be able to handle this result. So what kind of result are you returning to me? Right, so like if I try to do this, now we have our problem, right? Because we have different types of returns here. We have our question mark implicitly performs a conversion on the error value. And then what type are you? Result usize. Oh, interesting. Okay. So it's just a result usize. Is there no error? Error kind interrupted is basically what I could get. Let's see, map error, you could put a standard error in there or map error. Sure, the result type is result T IO error. Yeah, probably. So like if we did use like something like error, which I'm not like super opposed to, we could definitely do something like that. Then I would be able to like I was hoping not to be able to use external libraries, but yeah, I agree that like doing better handling than like just string like this would be better. So maybe for this, yeah, let's pull that in. Error. Bring in the latest. Okay. Overwrite result here. So then we just start getting results. And then I think I don't want to use a box though. At least for this first one, if possible. Because I think that will cause more confusion. So if I do results, how do I use their result again? I think that's all I care about is like the string coming out. Or not. Oh, I do have to. Okay. Oh yeah, you're right. That's I want command. And I guess like you could be a string, but because you're like now a result, this other one that can handle all these other types, I think that's going to be fine. Now inside of here, you result a vector of string, or can I do that? And then I want to command. You don't need to write the error if you bring error results. I guess that's true, right? Although this one is I need to create like a new error. Because like if the command length is 0, is 1. I need to create like a new error type. Can I actually create that off of error? Can I say error? I don't want to format it. I guess I just want to create like pass in a new error, but missing argument. Now you, let's see, so you are string standard error is not satisfied, required becomes impl error port, required from standard convert from. So you're the vector string that's going out, but I don't know exactly, like I don't want to necessarily do something like that. Can I do a error error? No, because it doesn't know how to convert over into that. How do I create an error? Or I guess I do need to create a I need to create an enum error, like basically a custom error. And then this could be, what is, what would it be? Missing argument. You believe is error report, not error? Let's try that. So here. Oh, that doesn't make it happier. It still can't convert from string 3-bound standard string standard error is not satisfied, required because the requirements of impl convert from string for error report. So like it doesn't know how to do that because it needs to create the, like, figure out what this is from that. Still use the bail macro. I don't want to panic though here. I want to panic at the main. So I want to build a question mark at this point in time, but I also want to create my own custom error. And that's where I was thinking like the strings would work, but I guess that's not proper Rust. So if I create like an enum for error, or like a custom error, and then this would be like missing arguments. Then you would have to be like this custom error. Then I have to implement impl error for custom error. And we're expected you that. Can I find trait? Derive debug and implement display for a custom error. Ooh, is that all you need to do? Derive. Okay, you know, derive debug, and implement display for your custom error. Implement display. Can I find, is it like standard display? Where's that under? Standard path display, oh, standard format display. Okay, so standard format display. This is not a tutorial for first language. This is a tutorial for after you've learned JavaScript and you want to go for like a second language that's more like server side, strongly typed, that kind of thing. So I'm not going to be doing like how to program. I'm going to be doing like how to program in this specific way, which is, you know, different than what you're maybe used to. Okay, so we need not trade items. Some say yes, some say it's not. Yeah, I don't agree that like Rust is necessarily the best first language to learn. I think that I do think that JavaScript, Python, those are really good languages because you can get like really fast feedback with running things, and it's like super high rewarding with like graphical stuff showing really fast. Null traits implemented, missing FMT. Okay, so let's bring in FMT, which returns a standard result, standard format error. Huh, you bring in a formatter. I don't think I've done format before. Returns a result. Can I actually do display as this? Well, like this figure it out? I don't think I've tried that. No, it won't. Can it find derive macro display? Okay, so this is not the drive macro. So I'll have to, not that one. We'll have to figure out the display for it. If I want to return like custom error for this, let's return, I guess, a match on like what our custom error is. So match on self. Is it just self? Custom error, missing arguments. In this case, we want to return an error. This is looking for a report. But if I do the report is missing arguments. Can I find formatter in this scope? I don't think you're in here. Are you planning on studying computer science next year then maybe? Yeah, like the target audience I have in mind is going to be for like after you've been working at a job for a little bit. So you have some like experience under your belt as a developer. But you're like sort of like in that JavaScript mindset and you don't really know any other languages, but you want to learn them. That's sort of what I'm going for. Now getting like this custom formatter for working, like that's sort of what I was thinking about, like staying with the string for a while and like just turning them into there. let's see. For the stream, well, for like the Sundays is going to be my tutorial days. So like I create these tutorials on Sundays, and then my weekdays are going to be like my stream tools and other things that I'm building in the morning before work. Okay, so this is going down a rabbit hole I don't really want to go down right now. I think I'll have to come back to this later and figure it out. Oh, no, don't apologize. Please don't apologize. I think for right now, we'll stay with the string, meaning that you are a string here, meaning that I can't really do this for you. I want to essentially match. Just hang on, talking coding. Oh, no, don't apologize. I love, that's why I have like questions, okay, and I love chatting about all coding. I think it's good. So then for this one, if it is an error, we take in our error. We're gonna return error, a new format, error opening file for, is this, oh no, error writing to file. And that. And then we have our okay, what are you upset about? We have our vec and format added this. Unreachable. Okay, so we try to write, oh, because, hold on. If it's an okay, we don't really care what we got out of it. Instead, we want to return this out. Okay, so no errors. Let's see if our tests work. Failed. It didn't, let's see, didn't add anything into here. If we take a look at our tests here, we run, pass the arguments in. Arguments is add and a new to-do item, and then assert equal. So I don't really care about the return value of it. So you didn't actually add it to the file and like save it. That assert should be 2. Well, it should be, we have 2 first, and then I want to add, and then have it be 3. Oh, wait, I need to get the items again. Ha. Yeah, I need to do, so I run, we add those in, and then we want to run again. So let to do items after add equals run, pass in the file name, and pass in an empty vector. And then this is going to be to do items after add. Okay, so failures, to do item, what happened here? Can list all to-do items, oh, can list all to-do items is failing now. And can add a new to-do item is failing, so that's a problem. So can list all to-do items, let's see, thread, panicked and assertion, left equals right. Left is this, right was, oh, look at that. A new to-do item was added in here. So we do have a new to-do item right here. So it kind of worked. Now let's rerun this, and we see it adding in there. The problem is we need to add in a new line before we add this thing in. So what is that going to look like? Also, I don't have a way to like reset this to begin with, so we might want to like deal with that. Okay, so to add a new line, I want to do new items in this. When I add the new line, we write to here. So here is, let's see, write as buff, so new to-do item. I kind of want to like append a new line to it first. But is there a way for me to like do to-do file dot like add new line? Like there's write all. For our new line, could I prepend? So like before, okay, we have our new to-do item here. Right, so new to-do item. Can I like format this? Then we'll convert into bytes. Essentially, I want that to have happen, but like /r/new line. I wonder if that will work. It did. Okay, so new to-do item shows up here. Can list all to-do items failed. Let's actually remove these. Okay. There you go. It successfully runs the first time. Now the problem is that if I run this multiple times, it's always going to fail because we keep on getting new items in here. Is that right? Right, because now it's saying like, hey, the list of here should only be too long, but it's longer than that. So we need a way to like reset the this file multiple times, essentially. But it is working in so that I can have these tests run. It opens up this file for reading. I can write to it too, and then that deals with that. If I want to reset this file in our main library, now these tests are all running in parallel. After the assert, then restore the contents. That's something that I can do. I'm kind of thinking that I want to have a function that like resets the file. So like let's say inside of here I have a it's not a test file, not a test function, but it's in the test section, and we'll like reset to-dos data. And so then in here I want to open up the file, like delete the file, create the file. I can create. And we'll truncate if it does. Does that reset it, I think? So I can create the file and open it in write-only mode. So I think that's what I want to do. So file create like that. So let's to-dos file equals file create, and the path is to-dos.data. we'll unwrap that. And so that sits that there. And then I want to insert into it. So let's say the data to insert is going to be, well, I think create, it says it truncates it. So I think that will remove everything in there. And then I want to add in all of this stuff in again. So if I then, oh, what is that going to be? We're just gonna have our string of like to write in. So like let file contents, like to do items, is gonna be a string that holds essentially both of you, but slash new line, so slash what is it, r new, like return back to the beginning and down one, and then you next, and that's the end of you. And then we'll just like to own this to make it a string, and then I want to write this out to the file. So to use file dot write, and our buffer is going to be the to do items dot as bytes dot unwrap, like that, and then be mutable. And now at the beginning of each of these functions, we're going to run reset to do's data like this. Now if I do this, heck, even if I like completely empty you out, it works. And now I can run my tests multiple times and it keeps on, is that true? Keeps on resetting it? It's the same still. That's interesting. Sometimes it's failing to reset it, whereas other times it's not. And also I can't see like what the contents are right here. So can list, all to do items failed. Left is 2, right is 4, as if it appended, like it didn't actually reset it for us properly. But then I run this again and it's all fine. Well, now it's running every time. I was wondering if like, because I know the tests run in threaded mode, but it should be synchronous when it's opening that files and like resetting it. But okay, I guess our everything is working now for this. So reset the file. And then there we go. Then everything is happy and we're doing good. So it is 1:20 my time. I've skipped. I don't eat breakfast because I'm on a intermittent fast from my my nutritionist. So I am really hungry because I need to go get lunch. So I think I'm going to end it for today. What we do have though is this as doer one about add a to-do item. So we've successfully are able to add our to-do items. Let's see. Let's add in really quickly what we did here. So we basically create a command. So extract, figure out what the command is. We want to then open file for writing. And append, append to item to file. And that's pretty much it for this. So then next, so the plan is next week, we're going to continue on, finish this up, maybe clean up the code, make sure it's like in the state we want to do, think about how we want to handle those errors in a little bit better way. And then once I do that, I'm going to figure out what the actual like path to get enough enough knowledge to there is, and then we'll figure out what our we'll like create our plan for the tutorials. So I'm looking forward to that. It's going to be great. Russ Jr., good morning, or I guess afternoon now. And thank you. Let's see, did I miss any? There's a bunch of chat about like languages. Microsoft developed C#, not C++. Backend Go is gaining popularity, yes. I mean, there's so many languages, front end and back end. That's all good. Okay, so I think we're all good here. I'm gonna go ahead and push up all these changes to GitHub. So let's see, can add a to do item now and push. And all of this is available under Bang repo, or if you're watching the VOD, it'll be in the description for the VOD. All right, and with that, is there anybody in the Rust team that's programming? Let's see. The comms is programming right now. Let's go take a look at what he's doing. He's doing Rust game dev. Fun and Dreams, game dev plus more. WebGL, Web GPU. That looks pretty cool. And Unity sometimes. What language is this? This looks like Rust. Yeah, he's using Rust Analyzer. Okay, this looks about fine. Let's do a raid. I will set this up. Where's raid? Raid. To Dicom Z. I'll start that up. All right, everybody. I won't be able to hang out for too long because I need to go grab lunch really quickly. But thank you, everybody, for stopping by. I'm going to switch over to my ending screen. I am doing these. I'm doing morning streams every single weekday morning from 7 a.m. Mountain Time to around 8:15 or so, and then I also have these Sunday streams from morning till around noon or so. And we went a little bit late today because I got a late start. Anyways, let's be good to Dicomez and say hi to him, and hopefully it's a good project. And with that, we're gonna start the raid. I'll see you next time. Bye.